Hello and welcome, Dr. G coming at you with another video. Today we are covering the Central Limit Theorem. This is a follow-up to our normal distribution video. And so today we are analyzing the scores from the Justice League's VR Danger Room. The average score for VR training missions is 21.8 points, and the standard deviation is 9.2 points. 10 training missions are randomly selected, super important. Round all answers to 4 decimal places where possible, and assume a normal distribution. What is the distribution of the sample means? I'm going to give a little note right here. The key difference between these problems and all of the other ones that you've done that's going to cause you a little frustration is the fact that I now have 10 as a sample size, and that means that my standard deviation gets divided by the square root of the sample size. I see many students miss that change to the standard deviation and get really frustrated in their calculations. The other thing that's really important for these types of problems is you have to be able to assume a normal distribution, either because it's stated like it is right here, or the sample size is large enough, which this is not. 10 is not large enough to assume a normal distribution. So that's why that's there. Okay, so that is my hint here at the beginning that will save you a lot of frustration. Now let's jump into the actual problem. The problem says, what is the distribution of the sample mean? Now, usually the answer is going to be something like n, right? That means normal, and you're going to have some blanks, right, that you're going to have to fill in. That's the mean and the standard deviation, okay? So here's what we're going to do. We're going to put our average score, the 21.8. That is our population mean. Perfect. Our population standard deviation is the standard deviation that they gave us, 9.2. And of course, our sample size is 10. Now, I don't have a value here, but that's okay. All right, so now, like we've done before, everything in yellow is required from the problem. This, and this, these 3 formulas right here are all the same from our normal distribution calculator. Again, I think this is where students mess up. It's this standard deviation that is different. The standard deviation of a sampling distribution is always smaller, and it's smaller by the square root of the sample size. So here, of course, I just have a cell reference. Here, I have a cell reference of the population standard deviation, but it's being divided by that square root. And then again, I have the normal distribution. There's the value, the mean, and the sampling standard deviation. And then again, the normal distribution is always true. For greater than, we just use the complement rule, and it's 1 minus the less than, right? And so that's perfect. And again, for our percentile value, I just need the norm dot distribution. And again, it's going to be that mean of the percentile, the mean, and the sampling standard deviation. Okay, so that's how we're going to work these kinds of problems. Because I didn't have a lot of room, each part is going to be on another tab. But when I go over to the other tab, you're going to notice that everything is basically the same. Okay, but now we want to know the probability that the sample mean is greater than 18.4361. So I'm going to put my 18.4361 in here. And again, my mean stays the same. My sampling standard deviation is smaller. And then the probability that greater than is right here, the 0.8762. That's the greater than. So the calculator is really nice for this. All right, moving along. What if we needed to find a between, right? So now I have a value, I have the percentile. It could actually be easier. And again, I do these things a little bit differently every time that I do it. I might have in my calculator like a little upper, a little lower, and then like a little between guy right here. And then what I would do is I would put this upper value in 23.3547, and that's less than, right? Less than, boop, copy. I'm going to go ahead. Now, the secret sauce here is I want to right click because I don't really want a cell reference here. What I want to do is I want the value only. So I'm going to copy that in there. And then I'm going to put the 22.0361. And again, I want that less than. I want that left tail. And so I'm going to hit copy. I'm going to hit paste. And then I'm just going to subtract the upper from the lower. Oh, I think I did not copy that correctly. Copy, paste special values. I did not. There we go. So again, that paste values is going to be really important. Otherwise, it's going to pull from somewhere else and it's going to be wonky. So this would be my between right there if you wanted to do it that way. What we did in the last video, though, was I did a lower and upper, and then I had a between here. And what we did was we went ahead and grabbed this. Oh, but I want the upper. Yep. And then we're going to put minus and then the lower. Perfect. Oh, but I got to get rid of this equal sign or I'm going to get an error for sure. So I just want to do the upper minus the lower like we did last time, right? And I hit enter. And then we can go ahead and put the 23.3547 in there. And now we've got the same answer. Let me go ahead and make that 4 decimal places. There we go. And so now we have the exact same answer there. Let me go ahead and copy this and we will paste it in with the little apostrophe so that you can see it. This feels a little crowded to me, but you may really like it. This seems like a nice solution, but you do have to do some copy paste stuff. And if you screw up one of the pastes like I did previously, that's not always great. So I'm really interested to see what you are all doing. If you could drop that in the comments, that would be super awesome. All right, moving right along to our next one. So now we have the percentiles, right? And so now I want to find the 63rd percentile. The 63rd percentile is always to the left. So all I have to do here is paste in the 63. That 63 as a percentage is going to go in right here. The norm dot inverse is going to calculate the value, and it is right there. And then the next one that we would do is find Q1. Q1 is the 25th percentile. So all I have to do is type in 25 and it pops right out. So this calculator is going to be super helpful for all of the central limit theorem problems. So that is great. Now, some of you are going to have professors and they're going to want you to compute with the sum of means, the sum of the sample means. And what will happen here is you'll actually have like a sigma. It's a capital, it's a Greek letter that looks like a fancy E with the probability, right? The sigma of the sample means, right? So you'll have that X bar right there. So if you have a problem like that, this is going to be slightly different, okay? What happens is the sum of the sample means that I'm not going to have one 21.8, but I'm going to have the sample size number of that 21 of 28. And so what I got to do is I actually have to multiply by the sample size. I have to do that as well for the standard deviation. Luckily, those are the only two changes that you have to make for the sum of means, which is super nice. So I'm just going to hit all copy, and we're going to go ahead and paste that in. I'm going to hit all copy. I'm going to go ahead and paste that in so that you can see it. And that's all we're going to do. That's the only difference there. I don't have to change this because the standard deviation and the sample mean are already changed by the formula, and so I don't have to worry about it. So all of these things, all the other formulas are going to remain the same. So it's super nice, right? So what is the distribution? The distribution is going to be the normal, right? And you're going to have the 21.8 and then the 29.093. Perfect, right? So that's what your sampling distribution is going to look like, and everything gets calculated off of that. And so I'm going to go ahead and copy this, and we're going to go over to our last problem for this particular video. And what if you want the sum of means that's less than 185.361? And if I do that, then it pops up, and the less than is the 0.1310 right there. If you got something out of this, if this was helpful for your homework, then that makes me happy, and I'll see you in the next video.